Christopher. Yes, good afternoon. I still remain Mr. Brown from Kappa Islamic Secondary School. At this time, we are going to handle L-level mathematics, and we are going to get specifically on chapter 2. We are going to be doing terminal on mechanics. I know this is always the most challenging topic when it comes to mathematics. That's why we realize that most of the people always run away from these numbers. And the launch arm must be between 12 degrees and 67 degrees. At the same time, two emergency response vehicles leave from the opposite end, A and B, of a 20 meter straight road. At the same time, one vehicle starts from right at A and travel towards B with a constant acceleration of 2 meters per second square. And another vehicle starts from the rest of B and travel towards A with a constant acceleration of 5 meters per second square. The intersection occurs where the vehicle is. Meanwhile, two rescue motor boats, 2 and 2, began moving on the left. Both 2 travel at a constant speed of 20 kilometers per hour on a bearing of 0.60 degrees, while both 2 travel at a constant speed of 10 kilometers per hour. At 2:00 p.m., the operation on the board observed that the boat speed is 4 kilometers US of speed. The intention of the operator until it requires as close as possible to speed, right? Investigate whether the rescue was successful. Part B. Investigate the point on the road where the particles will lead from air. In the part B, Roman 1, investigate Roman 1, investigate the cause that must be kept by you. 2. Pass as close as possible to B and the distance. So Roman 2 says, let the operator to the time when the cause will take place. That is what we are going to look at. Like I said before, that whenever you answer the scenario, you have to be looking at least a paragraph by a paragraph as you compare it with the part of the task. Like paragraph 1, they are saying during the exercise, the helicopter launches like this. That is the part A. When you look at other part A, you realize that the item is coming from the part of a projectile as affected in mechanics. The other projectile, I am going to look at the summary of the thing that is given. Alright, that is the speed. The same distance is given to where the picture it is horizontally. The picture it is horizontally, they are trying to do that. And now we look at a projectile, and they are saying that this one here was projected from a cliff. So if we look at that one there and our cliff, a cliff is something which is above the ground. So if this is that is our cliff, we are going next to that we are having an helicopter which is going to be on the cliff. This helicopter, it is starts from a cliff and then up to the level ground. So you realize that this movement is being guided by a speed u, whereby we say u is the same as 30 meters per second. Same as 30 meters per second, and we are looking for the armor of projection of the helicopter which is here, and they are saying the distance point up to the point of projection to the same as the picture. That can be read horizontally. According to our summary, the condition says that the angle between the degrees 20 degrees and 7 degrees. Whenever we go answer the final question on the projectile, what you have to look at, what are the things am I supposed to see for the question. Like when you look at the diagram so far, you realize that in the diagram we are having our image. This one is given by the horizontal distance. And the rest is not the angle of projection. The angle of projection is what we are looking at. Meaning that someone should not be talking about things like maximum height, because the maximum height here is not given. I may not be looking at maybe the time of flight, because what I can use here to get the time of flight is not given. Meaning that what I should be looking at here, because I'm doing the range, and you know that it is the only way I can get the angle theta. Meaning, I am going to take the horizontal end. So I'm going to say from the horizontal range. Right? That is given by R, U square. Thank you. Theta divided by D. Because D is acting as a constant value, I am going to include it in my summary here. And when you say my D is 0, is 9.8 meters per second. Yeah, remember it is an acceleration of light and is a constant value. So we are going to look at how I'm going to come up with the value of the angle. This angle here should lie between 12 degrees and 7 degrees. If I try to make this angle the subject, you realize that if I try to multiply, we are going to have R and D. That is if I look at this. Again, take off 2. U squared sin 2 theta. So we make the thing of the subject. We will have the side 2 theta. That is if I divide one side by U square, we will have R and D divided by U square. That's what we are looking at. So meaning that our 2 theta will be given by the sine arc of R and D divided by U square. And we have all of it. So I'm going to say 2 theta, the same as the sine arc of equal square times 9.8 divided by our U that was started, but this U is a square. So this one is after the started square. So let us see what is this I value of the theta. I'm going to press the calculator mostly for the first part. So we are going to have 60 times 9.8. 60 times 9.8. Then we divide by the circle square, which is the same as 900. So meaning that here we are going to have the sine arc of 0.65. 3. That is the current, but it does not matter when I write it to decimal place like the way I put. So I'm going to get the value of the sine arc, which is the sine inverse. Let us okay. Inverse of 0.6533. Okay. So this is 20 quarter point 8. I divide it by 2. So this is 20.4 degrees. But in our scenario, they are saying that for 30 million, the launch angle must be between 20 and 67 degrees. Meaning that when you look at the large angle we have got, the large angle we have got lies between the given range of 20 and 67. Meaning that in my conclusion, I'm going to say the launch is effective. The launch, they are saying effective. I will say, therefore, the launch, that's it. The launch is set in its angle, of 20.4 degrees is between 20 degrees and 67 degrees. Remember, that was concerning our part 1. So you realize that the rescue can also say blessing on the task. You can also say the rescue will be successful since the angle lies between the given range. There are many ways you can come to here. So which means any English I use here is always correct. So that's the best in my projectile. I told you before that projectile you have to look at you have to consider many things. Not that all the equations given there, or not that all equations of a projectile can do a projectile number. You have to look at what is given first before you answer a projectile number. Part B, investigate the point on the road where the particle will meet from point A. Remember, in somewhere there we said at the same time, two emergency response vehicles leave from the opposite end, A and B. The distance between A and B, or the distance between those two points are 20 meters. Meaning that in my drawing, I make sure that what is given between them is 20 meters, because A is going towards B and also B is going towards A.